Okay, multiplication. It says use an area model to organize your work. Simplify your answer by collecting like terms. So, if we start with question C, I don't think I need an area model to organize my work, but I think I'm going to use one anyways. And this is kind of based on some of the mistakes I saw earlier on. So first of all, notice that this first factor, right? Again, if I look at this big picture, I see something times something, right? So it's a multiplication problem. One factor times another. The first factor contains two terms, right? It contains the term 3x and it contains the term 1. When I say terms, I'm talking about things that are added together. So big picture, there's one factor times another factor. Um, that first factor contains two terms. The second factor only contains one term. So if I wanted to build a generic area model for this, right, it's pretty straightforward. I'm just going to have two terms by one term. So I could say, for example, 3x plus 1. It's the length 3x plus the length of 1 times negative 2x. Now, this is really nice. It's super organized. When I do my multiplication here, I've got 2 boxes that I need to fill in, and I'm going to fill that in by just figuring out the product of their length and width. So the first one is I'm multiplying a negative 2x times 3x. That gives me negative 6 times x. And the other box is a negative 2x times 1. Oh, I can't believe I just did this because that's the mistake I saw many of you make. When I multiply negative 2x times 3x, notice that there is an x times an additional x there, right? So that's negative 6 times x squared. So I've got to have that x squared in there. Negative 2x times 3x is negative 6x squared. And then I've got a negative 2x times 1, which is just negative 2x. So that product, right, is, and I can write it down here in this bottom box, is negative 6x squared minus 2x. Okay, so let's move up and look at the one above that. The one above it, again, when I look at this big picture, what do I see? I see something, right? I don't care what it is. It's something multiplied by something else, right? So that's my big picture. Now, when I look at that, I'm going to look at what are those somethings, right? And I can see the first thing here has two terms, right? Terms are those things separated by addition or subtraction. So I've got a term of x, and I could say a term of negative 4. My other two terms, then the second factor also has two terms, and it's got a 3x and a 1. So if I'm going to build an area model for this, I'm going to have a 2 by 2 grid this time. And across the top I might write 3x and then plus 1, and then on the left I might have an x and then a negative 4. So if I go in and fill in each of these parts, it's pretty simple, right? Because it's just length times width. Let's see if I can do this carefully this time. In the upper left hand box I've got an x times 3x, which would be 3x squared. That's nice. Then when I multiply x times 1, right, that's going to give me a positive x. And then I'm down below, lower left, I'm going to multiply negative 4 times 3x, which would give me a negative 12x. And then finally, I've got negative 4 times negative 1, which gives me negative 4. So two of these terms, right, two of these boxes are like terms, and I can combine them, right? I've got an x and a negative 12x, and because those are like terms, they're terms that have the same variables and the same powers on those variables, I can combine them together. So I can write my final answer as 3x squared, and then I would combine the negative 12x and the positive 1x as negative 11x, and then finally a minus 4. So let me write that. I should have written it over here in this line. Again, that answer was there were 3x squared and then minus 11x and then minus 4. Right, and then on the final one, again, big picture, I'm multiplying just two things, right? This is one of the things that I'm multiplying, and then it's times another thing. Well, the first thing that I'm multiplying it turns out that it has three different factors, right? there's a 4x squared, there's a 2x, and there's a negative 3. So if I wanted to build a model for that, I would probably use a rectangle that looked like this, and I would have 1, 2, 3 different columns, and I could write across the top here 4x squared, a 2x, and a negative 3. Now across horizontally, right, this next factor only has two terms. It's got an x and a plus 6. So I can go ahead and just write this as an x units and then 6 units. So the generic area model set up, let's go ahead and find the area that goes in each piece. This first piece is 4 times x to the third power. That's an x times x squared, 4x to the third. The next one I've got there is 2x times x, which would be 2 and then x squared. And then I've got a x times negative 3, which I would write as negative 3x. And then let's go down below all the way to the left. I've got 6 times 4x squared, which would be 24x squared. And then I've got 6 times 2x, which is 12x. And then finally, 6 times negative 3 is negative 18. So there are like terms here, and it's really important that we kind of identify them. Definitely 24x squared and 2x are like terms, so we can combine those. And we can also combine, of course, this 12x and this negative 3x. So let's go ahead and write down our answer, and I'll combine the like terms at the same time. So all the way over here. And I'm going to go ahead and write down, first of all, you can see that there was 4x to the third, 4x to the third power. And then I'm going to write plus, when I combine 24x squared and 2x squared, I get 26x squared. And then the next thing I've got in my x terms, you can see it's a 12x minus 3x, which is going to give me a plus 9x. And then finally I've got this minus 18. And that's awful that I've run out of room there. But the answer is 4x cubed plus 26x squared and then minus 18.